We begin logarithm with the laws. The first on the list is the product law, saying that if you are multiplying two things under the same logarithm of one base, all you have to do is add them up. And this applies to quotient law, which is the division. You subtract. And when it is exponential, the exponential becomes the coefficient of the log. And when you have an inverse, it changes the base of that log. Of course, the logarithm of 1 to a base is 0. And a change of base is you finding a base that is very common to both sides. And let's see the link between logarithm and indices as we have seen below. Log a to the base of s equals n means x raised to n equals to a. And the logarithm of a number to itself is equals to 1. And when a number is raised to the logarithm of its own base, it's equal to a, to the number itself. So there we have it. Now let's have a look at carefully selected 12 examples. If we have minus log 10, we have 0.0001. 0.001 can be expressed as 10 raised to the power minus 4. And so that is the logarithm of 10 raised to the power minus 4 to the base of 10. And of course, using the exponential law of logarithm, we have it. The index becomes the coefficient. And so, minus into minus 4, log 10 to 10. Logarithm of a number to itself is 1. So 10 to 10 is 1. And so the value gives us 4. Here, we have logarithm of 64 to x equals to 3. Using the link between logarithm and indices, we have x raised to the power 3 equals to 64. Expressing 64 as a power of 3, we get 4. Therefore, using the value of x equals to 4, we're able to find the value of x log 8 to base 2. And x log 8 to base 2, expressing 8 as a factor of 2, we discovered that would be 2 raised to the power 3. So making 3 the coefficient, we have 4 times 3, 2 to 2, which is 1. And then the answer there gives us 12. So log 8 root 2 to the base of 2. 8 root 2 will be done using sword. We have 8 raised to the power 2 multiplied by 2. That gives us 64 multiplied by 2. And that will give us root 128 to the base of 2. And expressing root 128 to be 128 raised to the power half. While the half becomes the coefficient, we express 128 as a base of 2, and that's 2 raised to the power 7. 7 becomes the coefficient. Multiply 7 by half, we got 7 over 2. Log 2 to 2 will give us 1. So therefore, the answer gives us 7 over 2, which is also the same thing as 3.5. So here, applying the law of the link between logarithm and indices, we're able to know that 9 raised to the power 3 over 2 is going to give you x. And of course, remember the law of indices. If a number is raised to a fractional index, the denominator becomes the root, while the numerator becomes the index. And so we have root 9 raised to the power 3, the answer gives 27. In the very next example, the logarithm of 27 to the base of x equals to x. And so, using the link between logarithm and indices, x raised to the power x equals to 27. Express 27 to be able to raise to a number itself. That would be 3 raised to the power 3. So comparing bases and comparing indexes, we discover that x equals to 3. In this very next example, we apply quite a few laws. First, we ensure that the 2, which is the coefficient, becomes an index, and then we'll go on to ensure that the subtraction sign becomes a division sign, and then the addition sign becomes multiplication sign. Remember the two first laws that we are given. When you are subtracting, it is result of a division, and when you are multiplying, it is a result of addition. So we use those laws here. So therefore, we have 16 over 25 divided by 72 over 125 multiplied by 90. And of course, when we're transforming division into multiplication, remember the primary school days? We apply that here. And so having carried out all the divisions, we are left with logarithm of 2 times 5 times 10, and that gives us logarithm of 100. Since the numbers are in natural logarithm is base 10. So therefore, 2 to log 10 becomes 1, and the answer is 2. Alright, to the very next example, we are going to see that we need something more. Now, here we have it. Log 6 minus 2 to the base of 2 equals to 3 minus log x to the base of 2. So from here, I'm going to collect like terms so that I can have all the log x on one side. And of course, applying the very first law, whereby addition becomes multiplication of the two together. So I have 6 minus x multiplied by x equals to 3. When I expand that, I'm going to get 6x minus x equals to 3. Now, you're going to use the link between indices and logarithm. So 2 raised to power 3 equals to 6x minus x squared. I'm going to collect like terms here, and of course in the end I will get a quadratic equation. So if I solve that by factorization method, the factors of plus 8 that will give me minus 6 when I sum them is going to be minus 4 and minus 2. Of course, minus 4 minus 2 will give me minus 6. Multiply that will give me plus 8. And so when I put that and I expand, collecting the factors out of it, I'll get x minus 2 and x minus 4 equals to 0. That means that the roots will give me 2 or 4 respectively. The next example here is something very interesting. You can see the values. And so, without wasting time, here I am. I'm going to apply the very first law of logarithm, and that is the multiplication law, the product rule. So here I'm going to have to multiply y plus 8 by y minus 8 under the same log. And then I have the 2 here becomes the index of 3, the other one becomes the index of 5. And of course, if I open the first one, it becomes a difference of 2 squares. And of course here I have 3 square 9 and then 5 square 25. Multiplying this, I can get that. So comparing the logarithms together, what I'm going to do is that I'm going to discover that it's just like when we compare bases in indices. And so comparing that, y squared minus 64 will equals to 225. And so from here, collect like terms. Y squared will give us 289, and taking the square root of that, we get plus or minus 17 as our answer. So we move to the next example. In this very example, we discover that we have half log 8 to the base of 4, 32 to the base of 4, minus 2 to the base of 4. So if I go on here, I can take one step at a time, having to do 32 to the base of 4 minus 2 to the base of 4. I take that as a division. I'm going to get half to the log of 8 base 4, and then 32 divided by 2 will give me 16. So here I have log 8 to the base of 4 plus 16 to the base of 4. 4 square is 16. So having take that, I have 2 log 4 4. Of course 4 is going to give me 1, having been a log to itself. So here I can take 8 and 4 and use the other law, which is the law of exchange of base. I express them all in base of 2. And so doing that, I'm going to end up getting 3 over 2. And so log 2, of course, we take themselves out, being log 2. So I'm getting half into 3 over 2 plus 2. And so you can open the bracket by multiplying. We get 3 over 4 plus 2. That gives 11 over 4. In decimal, 2.75. So in the next example, we are given that log 2 to the base of 10 is m. 3 to the base of 10 is n. Now we have to express log 24. 24 is going to give me 3 times 8. So I'm going to express 8 as 2 raised to power 3. And then the 3 of that becomes n. So here becomes 3 log 2. Of course, log 2 to base 10 is m. So 3m plus n. If log 2 to the base of 10 equals to the value given, log 3 as well, and log 5, we are to express 35 minus log 17.5. 35 can be expressed as 7 times 5, while 17.5 is expressed in fraction. We go on to continue the expression. The fraction becomes a subtraction, of course, following the second law that I gave us earlier. And so having done that, we can express 175 as 25 times 7. Since that is true, 25 itself can still be expressed as 5 raised to power 2. And so the multiplication here is expressed as plus, and then log 10 being in the natural base of 10 will give us 1. And so opening the bracket and expanding, we'll get all the values that we are getting there. And so you can see that log 7 will take out log 7 in subtraction, and then log 5 minus 2 log 5 is going to give us minus log 5 plus 1. So when I take this, log 5 given onto us is 0.6990, and so the value there will give us 0.3010. If 27 to the base of x plus 4 to the base of y is 5, the same value equals to 1. Now let m equals to 27 to the base of x and let n equals to 4 to the base of y in log. So this gives us a simultaneous equation which we can either solve by substitution or by elimination. So I'm choosing elimination. Let's add both sides together. We'll discover that we'll get 2m equals to 6, as n will cancel themselves out in plus and negative. And so m will give us 3. Substitute that m into any equation of your choice. I chose 2 here. So when I do that, n will give me 3 minus 1, which is equals to 2, respectively. Now let's recall that m as a value, 27 log 27 to the base of 3. So if I use the indices and logarithm relationship, x raised to the power 3 is going to give me 27, and of course we get x as 3. For the value of n log 4 to the base of y, use the same relationship and y is going to give you plus or minus 2 as we take the square root of 4. See you in the next one. Bye.